Hello friends, today I will solve a LeetCode medium problem on graphs. So the problem says maximum total importance of roads. So we are given an integer array n denoting the number of cities in a country. The cities are numbered from 0 to n minus 1, and we are also given a 2D integer array roads where roads of I is a pair ai, bi, which denotes there exists a bidirectional road connecting the cities ai and bi. So we need to assign each city with an integer from 1 to n, where each value can be used only once. And the importance of a road is defined as sum of the values of the two cities it connects. So we need to return the maximum total importance of all roads possible after assigning the values optimally. So let's understand this problem with a given example. So I have considered the first example. So here we are given 5 cities numbered from 0 to 4 connected by bidirectional roads or edges, and we are also given 6 edges. So our task is to assign unique values from 1 to n to each node, thus maximizing the total importance of all edges. So let's say we have an edge from city ai to bi, and the unique values we assigned is xi, yy. So the importance of this edge will be xi plus yy. So the importance of an edge is defined as the sum of the values of the nodes it connects. So it means a node's value contributes to importance once for each connected edge. So it means the nodes with more connecting edges should be assigned higher values to maximize the total importance. So let's assume the unique values assigned to each node are x0, x1, x2, x3 and x4. So the importance of edge 0, 1 is x0 plus x1. Similarly, the importance of edge 0, 2 is x0 plus x2. Importance of edge 1, 2 is x1 plus x2. Importance of edge 1, 3 is x1 plus x3. Importance of edge 2, 3 is x2 plus x3. And the importance of edge 2, 4 is x2 plus x4. So if we add these values, we will get total importance. So after adding, the values will be 2x0 plus 3x1 plus 4x2 plus 2x3 plus 1x4. So if you see, the unique value assigned to node 0, that is x0, corresponds to 2 times in the total importance. Similarly, for node x1, we can say the degree is 3, that is node 1 is connected to 3 edges. Similarly, node 2 is connected to 4 edges, node 3 is connected to 2 edges, and node 4 is connected to 1 edge. So our goal is to assign x0 to x4 in such a way that the above sum is maximum. So if we follow the greedy idea, that is to assign maximum value to the node having higher degree, then we will get the maximum sum. I know that I can assign the values from 1 to n. So the idea is I'll assign lowest values to the node with smaller degrees. So the node with smallest degree is node 4. So I will assign the lowest possible value, that is 1, to the node 4. So x4 becomes 1 and this term becomes 1 into 1, that is 1. Now I will consider the nodes whose degree is just greater than 1. So the nodes are nodes 0 and 3. Now the next possible unique value is 2. So I will assign the value 2 to node 0 and the value 3 to node 3. So the actual node number doesn't matter here. We are just concerned about the values we are assigning. So I'll assign the value 2 to node 0 and I will assign the value 3 to node 3. So this term becomes 2 into 2, that is 4, and this term becomes 2 into 3, that is 6. Now I will consider the node 1 whose degree is 3, which is just greater than 2. I'll assign the unique value, that is 4, because 3 is used. So this term will contribute 12. Similarly, I will consider the next node having degree greater than 3, that is the node 2 having degree 4. So I will assign the next unique value, that is 5, to this node. So this term will contribute 4 into 5, that is 20. So the total importance value will be 4 plus 12 plus 20 plus 6 plus 1, that is 43. So if we follow this greedy idea, that is assign the highest possible unique value to the node having highest degree, then we will get the maximum importance value. So the approach is, first we need to calculate the degree of each node. So here we will create an array to store the degree of each node. Then for each edge or for each road, we will increment and for each edge we will increment the degree count for each node. Now the second step will be sorting the nodes by degree. So here we can use library sort function or counting sort based approach. We can use an extra auxiliary array of size n called frequency to store the frequency count of each degree. Now the third step is assign values 1 to n to nodes. That is, we need to assign unique values to each node. So after sorting, the nodes are arranged in increasing order of their degrees. So we'll follow this greedy idea, that is assign higher values to nodes with higher degrees. So now I will code the solution. So first I will declare a array called degree to store the degree of each node. This is an array of size n. Now for each edge, I'll increment the degree of nodes connecting that edge. That is, for each road in roads, I'm incrementing the degree of both the nodes connecting that road. Now I'll use the counting sort based approach. I'll declare a array called frequency that is of size n. So this array store the frequency of each degree. The degree can be in the range from 0 to n minus 1, that is 0 for an isolated node and n minus 1 for a node connecting to all other nodes. So for each degree, I will increment its frequency. Now I'll declare a result variable that is initialized to 0, and I'll declare another variable called value that is initialized to 1. So this value will be unique and assigned to each node. Now I'll iterate over the degree of frequencies, and for each frequency I will assign the values in ascending order. So for int, so I will run an inner loop, that is frequency of I tells me the number of nodes with frequency I. So I will assign that many number of nodes unique values. So I will update the result to I into value plus plus. So I tells me the degree of each node, that is I edges are connected to that node, and I will multiply it with the unique value val, and I will increment the unique value. So at the end I will return the result. So let's run it for the sample test cases. Sample test cases are running fine. Now I will submit it. So it's working as expected. So let's discuss the time and space complexity. First, I'm declaring an degree array of size n. Now I am iterating over each edge. So this step will take big O of edges time. That is, in an undirected graph, the maximum number of edges can go n into n minus 1 by 2. So this step at the worst case can be big O of n square. This step is big O of edges, that is the size of the roads array. Now I am using the counting sort based approach. I am declaring a frequency array of size n, and for each degree I am incrementing its frequency. Then I am linearly traversing the frequency array, and if the frequency is greater than 0, then it means this many number of nodes has degree of I. So this inner loop in total runs big O of n time, that is the total number of nodes, and the outer loop runs big O of n time. So this step is linear even though we have a nested for loop inside, but this inner loop in total runs big O of n time. So the time complexity will be big O of n plus edges, that is the number of edges can go till big O of n square in the worst case, and the space complexity will be big O of n, as we are declaring two auxiliary arrays of size n. So I have attached the GitHub link in the description for sorting based approach and counting sort based approach in the description. Please do check it out. If you like this video, please subscribe, and if you have any comments or suggestions, please post it in the comment section. I will be happy to help. Thank you.